In today's video, we're going to be reviewing choosing a method. So your learning target is to choose the best strategy to solve a system of linear equations. When you have a system of equations to solve, how do you know which method to use? Today, you will focus on how to choose a strategy that is the most convenient and efficient for solving a system of equations. So which method is best? If you can pause this video and think for yourselves what might be the reasons for using each of these methods, go ahead and do that before I go ahead and go over it with you. So I should use the equal values method when two equations are equal to the same variable. Let me show you an example of this. Say you have y is equal to 2x and y is equal to 3x minus 1. Since both equations are equal to y, it's best to use the equal values method and equal them to each other to solve. I should use the substitution method when one equation is equal to a variable. So an example of this would be if you have y is equal to 2x, but then you have maybe 3x plus 2y is equal to 0. Right here, only one of your equations is equal to one variable, so you can substitute it for that variable. And that's when you should use the substitution method. I should use the elimination method when two equations are in standard form. So for example, if you have 2x plus 2y is equal to 8 and 4x minus 2y is equal to 7. This is when you would want to use elimination, when you can make opposites and add the two equations together to eliminate a variable. So now that we've reviewed when to use which method for the most efficiency, let's go ahead and try it with a word problem. I know these can be difficult, but let's go ahead and work through it together. So Erica works in a soda bottling factory. As bottles pass her on a conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks a bottle before she can cap it. She gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents from her pay for each bottle she breaks. Erica is having a bad morning. 15 bottles have come her way, but she has been breaking some and has only earned 6 cents so far today. How many bottles has Erica capped and how many has she broken? So we need to write a system of equations representing the solution. There's a lot of information here that's not important, and then we have some very important information. So her working in a soda bottle factory or bottling factory, how it works, that's good to understand and for context, right? Knowing she breaks bottles, important to know, but that's not going to necessarily help us in creating equations. What we do want that can help us is she gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents for each bottle she breaks. So that's important to know. We also need to know that 15 bottles have come her way. So right there is one equation. 15 bottles have come her way, but she has been breaking some, and she has only earned 6 cents so far. How many bottles has Erica capped and how many has she broken? So that's our question right there at the end of all that information. That's what we're answering, okay? So to write a system, let's write some let statements first so that we can define our variables. We've got two things working on here. We've got bottles broken and bottles capped. And we want to know how many bottles she has capped and how many she has broken. So I'm going to use C to equal the number of capped bottles and B for the number of broken bottles. Okay. And now using those two variables, C and B, I'm going to write my equation. There's usually an equation that you write that represents the two things coming together for a total. We know she had 15 bottles come her way. So I'm going to write the number of capped bottles plus the number of broken bottles is 15, right? She's had 15 bottles come her way, some capped, some broken. We don't know how many, but added together, we know she's had 15 bottles go past her. Then the other one starts talking about cents, and usually the second equation will have to do with some kind of unit of measure. So in this case, it's cents. Sometimes it's dollars, ounces. Okay, so look for those clues in a word problem. Here we've got 4 cents for each bottle she caps. So for the number of bottles she caps, she gets 4 cents, but they deduct 2 cents for everyone she breaks. So they subtract 2 cents for every bottle she breaks. And she has earned 6 cents so far. So I've just written a system of equations representing the situation, including defining my variables, which is super important. Now, I work with cents here. They just make sense to me. What you can do is change it into whole numbers, like my answer has here, right? Instead of putting 0.04 plus or minus 0.02b equals 0.06, you can also change it to whole numbers, which you can do by multiplying or dividing by 10, 100, 1,000, depending on how big or small your numbers are and how you want them to be. So now that we have our equation, let's go ahead and solve. So looking back at these two equations, what would you say would be best to use in this case? I can see really good arguments for either substitution or elimination. I will say if you are comfortable changing these to whole numbers, then elimination would definitely be better. Multiply everything here by 2, easy peasy. I'm going to do it the way I did it with the cents. And so if I have C plus B is equal to 15, right? And I have 0.04 C minus 0.02 C is equal to 0.06. I'm going to go ahead and use substitution. I'm going to change this one a little tiny bit. I'm going to move my B over. So I'm left with C is equal to 15 minus B. And check that out. Now I have a variable equal to an expression that I can substitute right into my second equation. I can put this for the C over here. It looks like I made a little mistake. Hopefully you caught that. This is B, right? Minus 2 cents for every bottle she breaks. Sorry. So let me go ahead and start my math. So if I'm substituting it in for C, I'm going to have 0.04 times 15 minus B minus 0.02B is equal to 0.06, running out of space, sorry. You're going to do some math. You're going to have to distribute, subtract, like terms and all of that. And once you do, you should get that she has capped 6 bottles and broken 9. So because we were, let's see if I undo, we were figuring out what the variable B is, that means you would have gotten that B is equal to 9. What do we do with that information? We'll remember from previous lessons, we plug it into one of the original equations to get the second answer. I'm going to choose this one, a lot more efficient than dealing with all of these decimals. So C plus B, which I now know is 9, is equal to 15. Subtracting 9 from both sides, I get C is 6. So Erica capped 6 bottles, but she broke 9. Now that we worked through that, let's go ahead and try these simpler equations. So for each of these systems, decide which algebraic solving strategy to use. That is, which method would be the most efficient and convenient? The substitution method, the elimination method, or setting the equations equal to each other, which is the equal values method. And then let's go ahead and solve them. So for this first one, what do we think is the best method? I'm going to say substitution. And that's because one of these variables is already equal to something. And so I'm just going to go ahead and plug that in. for right there. So 3 times x, which is 4 minus 2y, minus 2y is equal to 4. I'm now going to distribute. I get 12 minus 6y minus 2y is equal to 4. I'm going to combine like terms. 12 minus 8y is equal to 4. I'm going to add 4 over here. Oh, I'm sorry. I'm going to subtract 12 over here, which gives me negative 8. And then I'm going to divide both sides by negative 8, which gives me 1. Once I have one variable, I'm going to plug it into one of the originals. So let's do the first one. X is equal to 4 minus 2 times y, which is 1, 2. So hopefully my answer is 2, 1. Let's see. Nice. We did it correctly. Let's go ahead and try this next system. Which method would be best? Elimination. It looks like I need opposites though. So I'm going to go ahead and multiply one of these. It doesn't matter whether it's the top or bottom by negative 1 to make these opposites because they're the same right now, which is awesome. But I want to add them to be 0. And so in order to add them to equal 0, one of these needs to be negative. So I'm going to change this to, I now need to distribute my negative 1 everywhere. Negative 3x minus y is equal to negative 1. And my bottom equation didn't change. So I'm not going to do anything with that. I'm going to add the two equations together. Negative 3x plus 4x is positive x. This eliminates. Negative 1 plus 2 is 1. So hopefully 1 is x. And now I'm going to plug this into one of the equations. Let's see, 3 times 1 plus y is equal to 1. 3 plus y is equal to 1. I'm going to subtract 3. Is y equal to negative 2? Let's see. Negative 1, negative 2. Awesome. Oh, no. Oh, no, that's my, yeah, there it is. So it was 1 and negative 2. Awesome. Let's try 2 more examples. The first one is x is equal to negative 5y plus 2 and x is equal to 3y minus 2. What method should we use? We're going to use the equal values method where we equal them to each other. So negative 5y plus 2 is equal to 3y minus 2. Since they're both equal to x, we can equal them to each other and start to solve. Let's see, I'm going to add 5y over here. So that should give me 8y minus 2. I'm going to add 2 over here. So I'm going to get 4 is equal to 8y. And then I'm going to divide both sides by 8. And I get that y is equal to 1/2. And that is correct so far. And what do we do with that? Well, we're going to plug this into one of our equations. Ooh, this one will be a little spicy. Okay. So let me go ahead and plug it into this one right here. So x is going to be equal to 3 times y, which is 1/2 minus 2. I have x is equal to 3/2 minus 2, which is 1.5. And 1.5 minus 2 gives us that negative 0.5 for our x. So we solved this system of equations using equal values, and we got negative 1/2, 1/2. And then our last example. 2x minus 4y is 10, 2y plus 6 is equal to x. Ooh, this one's a little bit tricky. Okay, so which method should we use for this? And I'm going to say substitution because even though this to me told me elimination, but the second equation with the equal to variable told me substitution. And so I want to substitute this for x here. So let's go ahead and do it. I've got 2 times x, which is 2y plus 6, minus 4y is equal to 10. I need to distribute my 2, so I get 4y plus 12 minus 4y is equal to 10. I need to combine like terms. 4y minus 4y is 0. And then I've got 12 is equal to 10. Uh-oh, what happened here? We eliminated our variable. So when that happens, when we're left with no variables at the end, we have to think to ourselves, is this statement true? Is 12 equal to 10? If it's not true, then your answer is no solution. If it is true, if at the end you had say 10 is equal to 10, it would say infinite solutions. Infinite, yeah, I wrote that right. Solutions. Okay, and so let's go ahead and see if we got that right. No solution, exactly. So just be prepared for that as well. I hope this was helpful and thank you so much.